We'll flip the screen here real good. All right. Got the Utron maglev. I just decided to put the maglev on the outside. Works pretty good. Sweet. I'm gonna get this out of here just in case. Hello, hello. There we go. Get that up. All right, so this is an awesome little rotor here. It's 5 by 5.5 inches. So it's not quite 6 inches. But when you got 4 mags in there, huh. The rotor appears to be stuck on the pole. I'm going to need both hands to get that off of there, but that's all right. It's stuck in the right spot. That's all that matters, really. All right, so like this operates really well at 25 volts. About 5 watts, in between 2.5 and 5 watts. All right, so there it is. Is this like the best way to run it with like less wattage in? I don't know. It's going pretty slow right now. See, 2,500 divided by 4. No, it's not going that fast. But if we run with just one of these gray coils instead of all 3 of these coils, it'll go, you'll get 1,000 RPMs for sure. But it'll be like up around 11.75 watts. So we'll be pumping a lot more amperage with the shorter coil. Hello. How's it going? I was thinking about, since we're running so good at such, a higher voltage, applying one of these and seeing if we can just jack it up even more. Hello, hello. So this will go up to 345 volts of DC. So I don't know. I'm thinking about hooking that up for sure. So this is the trigger coil right here. It's just an external trigger coil. We can move it around and stuff. You hear that pick up right there? That's awesome. I just moved it a little bit to the right, and we got awesome speed increase. See, but when you got the bifilar trigger coil, you can't do that really and have it make sense. Oh, let's see. Let's see where are we at. That sounds beautiful. Oh yeah, we're almost to 1,000 right now. That's sweet. Well, 3,700. Let's see if I got that right. Yeah, 3,700. And then you divide by 4. Hello, hello. No, that's the RPMs. And that's, you got to divide that number by 4. So it's almost 1,000 RPMs. Ooh, that sounds even better. That's so good. Listen to that. Yep, we're above 1,000 now. 4,100. Sweet. All right. You divide that by 4, you're above 1,000. That's so cool. Now, I'm not really doing anything on the opposite side of this. It's all motion right now. It's all about kinetic energy and applying voltage to make it spin faster. I haven't hooked up anything to generate with. I mean, it's already generating, but it's like I got no meter reader. You know, there's nothing. I got no BEMF connections. I've got nothing on here right now. This is the bare bones. The only thing I'm really experimenting with right now is the external trigger, and it's freaking awesome, in my opinion. Hello, hello. Yeah, no need for such a high amount of voltage to make these little things spin. Maybe, maybe something bigger or something go faster. You know, like I could see 3K volts, something going really fast. This is only, let's see what it is now. It's just above 1,000 RPMs, I'm pretty sure. Yeah, 400, 4,000. There we go. That's where we're at. And then divide that by 4. So, yeah, like 1,050 RPMs. Good morning, good afternoon, everybody. Good evening. How we doing? This is Papa Bale. What's going on? This is awesome, man. This is so cool. You know, I could only get it to go, 1,000 maybe, but just it actually gets hot if you do that for a little bit. All right, so I've got another project also that I'm working on. I'll move the camera over there in just a second. See, and when it's off center, the coil just a little bit into the way that it's turning that way, spinning that way. So you move it this way a little bit, and you get a much greater response. And so that's a benefit of the external trigger. You can move it around. That's a plus. With the bifilar trigger, you're kind of stuck with the drive moving along with the trigger, which isn't bad. I'm saying the bifilar is pretty strong too, but you're never going to get it like this at the cost with the same coils. Just not going to happen. All right, so here's the other project. This is the Utron, and I've decided to maglev it, and it's pretty smooth. I'll turn it on real quick. I got it working with the external coil right now. I'm working on a rotor that'll fit in the middle of it, but I need a battery that's non-magnetic, has no magnetic components to it at all. That's what I need. And I don't know if it exists, or do I have to like make it myself? If I get a battery that can fit on this, that's the other thing. It's got to fit on this rotor. And then this rotor goes in the middle of that. But yeah, that's where I'm at with that. Hello, hello. Look at that baby go, man. That's awesome. Yeah, is that a fan? That's funny. It's a Utron, man. It's not a fan. There's no wind on that. This has got to be one of those things that has the least amount of drag. Utron is a shape. It's a shape with two cones put together at the fat end, and that makes a Utron. And some people debate that that's the shape of the universe, where the extent of the usable light is expended, and when that boundary gets created, it's the shape of a Utron. So basically, when entropy catches up with the universe, there's a boundary that gets created. So, like the light of the farthest star reaches as far as it can, there's a usable range, okay? And the usable range is what I'm talking about. Not everything that goes beyond that, because it doesn't matter. It really doesn't. I gotta say that there's a three-dimensional universe, and that's what matters to everybody who lives in it. It's gotta matter, you know. The third dimension is cool. If the singularity, I mean, just to put this out there, if the singularity is real, then your body is existing in many places all at once. Because that means you got infinite singularities inside of you, and the amount of space that it takes you to exist in a three-dimensional realm. So, you know what I'm saying? You exist in a range of on a spectrum. And, you know, this is a representation of the universe existing on a spectrum. So it's like it blows up from the center, right? And then it expands outward and upward. And that's what it would look like and as it expands. I was just, you know, thinking about, you know, quantum stuff and all that, and just thinking about the singularity itself, you know, just that point, that spot, you know, where it just not even a black hole or anything like that, just that point, that dot, whether it be empty or full or whatever it is, you know, that dot. And how many of those dots actually are inside of this space that I take up? And when I move, when I walk, that space changes, and everything about my frequency and the way it interacts with my environment is different every step I take. You can like try to say that and bunch it all into one, you know, constant, but your environment is not a constant, okay? No. Tell me more about it. That chip, man. Sorry, I got off. I got into a tangent there. Like, had to get it all out. You know what I mean? Now, see, you know, yeah, I get the ether thing and using the ether, because it's like, let me just try and put it this way. You know, this point right here in the middle of that high voltage symbol, there's a transformer in there, and I can't put my finger in the middle of that because there's a transformer there. And that is, there's a philosophy that goes behind that, and it's uh, same place, same time, right? That can't happen. Same place, same time, can't happen. Same place, same time, can't happen in a three-dimensional universe because there's already something there. But in the ether, everything is already there. So you can move that in and out of that space, and then you can put something else there because it's all already there. It's just in a three-dimensional world, you can't put both of these things there at the same time. So time is real, man. Time is very real. This is a pulse motor. And currently it's only hooked up the one way. I'm going to put 25 volts into it. There's no multimeters hooked up to it. It's hooked up solely for my enjoyment and your enjoyment to watch spin. There's no, you know, I don't, look at that. All right, so the external trigger, this is what's timing everything right here, this coil. And it's hooked up the same way a bifilar trigger strand would be hooked up. Except the awesome part about this is I can move it around and get a better situation on the timing. So that's awesome. Yeah, and I've always debated the, you know, the benefit of having an external trigger. One, it's cheaper. You can back it out and it'll be even more cheap. You know, since you get it, once you get it going real fast, you can move it out. So this is like 5 watts. Hello, hello. This is maglev on itself. So I got 4 Neos in there. Michigan. I've lived everywhere in Michigan. Yeah, I've been in the UP, man. Been there, and it's awesome up there. Oh, I live in Lower Michigan now, but yeah, man, I got no complaints about God's country. Even the snow, it's worth it. No, man, I'm not an engineer. If I took an engineering, became an engineer, I could do this, but I'm not an engineer. Yeah, okay. Yeah, I guess I'm a tinker. Like if we were playing a video game, I would definitely be the tinkerer. This is a pulse motor. It's a DC brushless motor. Um, this is the timing coil, trigger coil. That's my setup right there. And here's my power supply. 25 volts in, zero point 0.2 amps. Boom. I think that's pretty good speed for all the coiling that's here, man. I mean, we got 1,500 turns of 20 and 1,500 turns of 20 over here. And we got like 3,000 turns of 24 over there. Yeah, there's nothing different here. I'm not trying to alienate myself. I got enough of that going on already. I don't need to do that to myself. All right, here we go. So let's take a look at the other one over here. All right, so I decided to maglev this thing, and let's turn it on real quick. Now, let me show you the inside of this in just a second. There's a source power for it currently. However, I'll show you the inside. I'll show you what I'm planning on doing with it. Man, and I mean that sincerely, man. All right, we're gonna shut this down while I'm over here messing with this. Don't want too much going on. Ah, man. See, what happened is I had to super glue the bearings on there, and I think But when I, jostle it off, it should be all right. And then I just gotta sand the pole down a little bit. Some really fine sandpaper or something. All right, I'm lifting this up. All right, there it is. I don't know where the rotor went right now, but it's supposed to fit in there. And there's a little magnet that goes in that little hole in the bottom, and it gets magleved inside here. And then it's it's supposed to be a counter rotator in the interior. Wow. Anyway, yeah, it's a counter rotator, and the electromagnets are supposed to be, and the power supply, it's supposed to be in the center. The demo over here. Okay, the demo's right here. External trigger coil for your enjoyment. Short-tempered with me, man. Yo, what up, Mike? How's it going? Oh, shit. Sorry. There we go. Oh, man. All right, let's see what we got here. Hey, hey. All right, there we go. I figured out what my problem was. And I've been going really good all day. I haven't done that all day. Clip that coil when I spin it. But here we go. Sweet. All right. Yeah, man. For those of you who do have a mental illness, I'm one of those people, man. I have extreme bipolar. And I'm not afraid to admit that. If you don't like it, you can leave. All right. And, I do things all the time that I don't mean to do, and it sets me back tremendously. I have a really hard life based on those two facts alone. But, this is going really well, I think. I mean, I have to rework the whole the rotor in the middle because it's a little bit too big. I wish I had a bigger printer, and then I'd make a bigger Utron, and then I could use my rotor, but now I'm just going to make a smaller rotor. Yeah. So just out of and I look, man, I got it up there. I had to get it off there just to see if it would go faster. And I got the external trigger coil, the external coil working right now. And that's 12 volts, so in order to get it to go at least as fast, I'm going to need to have a 12-volt battery supply in the center. I don't know if that's going to ever happen, but wow. Oh, I left my tach meter over there. Hell yeah. Yeah, man, yeah, that's awesome. Right now, I just watch it spin, bro. Hello. That's all I do with it right now, and that's all it'll ever do. It's a toy. It's not industrial by any means. It's definitely more in the range of, you know, toy for somebody who likes to play with electronics. But I love it, man. It's great. I think that's going around 1200. Straight up, man. That's sweet. All right, let's see what we're working with right now. So this one is only going that fast. That sounds interesting, though. Maybe I'm looking for a non-magnetic electrical power source. The 9 volt that I was using earlier just had too much magnetic pull on the magnets, so I can either make the magnets smaller, or I gotta get, a power source with less of a magnetic pull on it. Water sounds like it would be that thing. Yeah, it's just too close quarters for there to be a battery in there that is magnetic. And I think everything currently has some sort of pull to it that generates power. Ooh. Does he now? Or did he then? Which one is it? Yay, almost 4,200. Nice. That thing's still spinning. That's awesome. It's got really good bearings. All right. With this particular situation, I'm not trying to generate power at all. So it doesn't matter. There's going to be nothing to even do with it. I mean, the best it can do is cycle back into itself. And I might set something like that up. But yeah, I ended up with like 14, just chilling out right now. It's still going like 12. That's awesome. Yeah, this one right here is just a toy. I mean, you can set something up, but when it's finally finished, it's all gonna be inside of this thing, and the shell is gonna spin separately from the rotor in the middle, and it should spin the opposite direction. So yeah, I'm down to put more power in, dude. That's definitely okay with me. Sky's the limit, man, with the power in. But I can buy one of these power supplies that'll do like 63 volts with an 8 amp draw on it, and that's the only way I'm getting 50 volts. Yeah, I'm not buying. I've refused to buy another thing in regards to any of this stuff. I'm gonna roll with what I got, and if it's not good enough, that's okay with me. I don't really care too much. I mean, I care enough that it's been what I've been doing for like the past 2 years. Yeah, I'm into it. But I mean, yeah, man, I what everybody like thinks I should be doing, I don't know about all that. And like all the stuff that I need, quote unquote, I don't know about all that. All right? I don't know about all that stuff that I need. I don't know about that stuff, all right? Yeah, that's going to burn a hole in my pocketbook, and I just don't give a freaking care about it anyway. Buy it for me. Send it to me in the mail, and we'll do it that way. You know? Thank you. Thank you. Thank you. I think it's pretty awesome. A friend of mine, Hall Effect X, turned me on to Otis T. Carr's contraption. And this is just a piece of it, you know? This isn't the contraption itself. This is just a piece of it. And there's 6 of these things that go around, uh, a big wheel. And then there's 6 aluminum plates that are in, shaped like that, and they go around. That's just like a wing of a plane. But it's done like that to catch the eddy currents on itself, and you use the plates to move past the neutron, making the neutron spin in a counter-rotating direction to the main rotor that's spinning, which is the external ring. And then there might have been one of these in the center, a big one with a crystal or some energy source in the center. I think it might have even been as simple as just a self generating source made out of a neutron. you know and anyway, the faster it would spin, the faster those neutrons in the wheel would kind of rotate, further disrupting. What it does is it gets a magnetic or a grip on time, okay, and it starts to basically unravel it. Time is just part of an equation. It's so you can exist in three-dimensional space. So you can move in three-dimensional space. It's all for you. It's not some trick or game or scandal. You know, you don't like pass on because of time. That's not what passes you on. It has nothing to do with it. And we use it as a unit of measurement, I believe. How long something has been around for, but it's different than that. That's more of an echo of time than time itself. Time is more about right now than anything else. Heck yeah. I don't know. I like unwinding every once in a while. Just trying to keep it on the same, pulse motor wavelength and stuff. I mean, this stuff is directly interconnected with like time and stuff like that because of how people have tried to manipulate it. And I've had um, I don't do that. I mean, maybe I am doing that, but I'm not doing it intentionally. You know what I'm saying? I don't care about that, but it might be happening anyway, regardless whether I care about it or not. So, yeah, I think it's awesome. Yeah, I believe it's so much an intricate part of our existence that we can't be without it. You know, it's not something that I don't even think being without it is a thing, really. No, sir. Let me show you how much this costs. That's 25 volts, 200 milliamps. Not free. So basically, what's been explained to me is that there's a possibility, and you can kind of hear it as it moves, that the magnets here are gripping time and pulling it with the rotor. That's what the hypothesis was laid before me. And then it was, further uh, refined to having the electromagnets on the center part spinning and having the stator be the permanent magnets. So I've got a few builds like that, and that's pretty cool. Does it, change anything? I don't think so. Not that I can immediately tell. I'm not any older or younger. Sorry, buddy, I can't roll a J. I made this painting one time a long time ago, and it was a smiley face, a walking smiley face that was pointing at you, and it said "Have a nice J" on it. It was pretty cool. Yeah, and if you don't know, I paint. I paint a lot more than I do pulse motors, so you're probably going to see a lot more of that from me. I just finished one actually. It's pretty neat. So the external trigger coil off to the right a little bit is going to be your best bet, and have all these lined up at the 90 degrees for this motor anyway. And they're all different. I mean, this is 20 gauge, 20 gauge, and 24 gauge in series, and I'm still pulling 200 milliamps using uh, the trigger coil. Now, I was messing around with this earlier today. It's a Hall effect sensor, proximity sensor, and it works all right. Works pretty good. Can't complain, but it's not. It wasn't as smooth. I have to mess around with it a little bit to get it to where I like it. So yeah, I just got my car out of the shop, and I went shopping, and I'm broke. So that's awesome. At least I got to go to the store. I'm like, yes, car's out of the shop, going to the store. And I drove around just for like 20 minutes, just because I was like, oh my God, it's been a while. I miss you. um, yeah. So I was playing with the same build using my paper clip, and it works really well with single file coils, because these are just 20 gauge. There's nothing else, no bifilar or anything like that. And so the only time I can ever use them is when they're in series or when you got an external trigger of some kind. External. Either Hall effect, reed switch, or coil like this. So cool. All right. So I got to bring in that rotor just a little bit. And then I got to make my, I got to print my own bobbins. There it is. And they fit right on those pegs, but those pegs will obviously be a different size. See, there's one right there. It's on there now. But I got to bring it in like a little bit, like an inch. Not an inch, like a centimeter, not even a centimeter, like a little bit. I just got to make it so it fits. And it was so close, like so unbelievably close. But it was just a little bit too tight. And that's just how it breaks down, man. That when you're eyeballing stuff, that's how it breaks down. You either make it the first time or you make it the second time. And I mean, I measured it, but it's on a maglev and it's bouncy. And yeah, it needs to be just a fraction of an inch smaller on all dimensions. I don't even know what that means, man. That is looks like an ignorant person's way of saying, I don't even know, man. I can't bring myself to that level. What does that mean? Yeah. Why don't you roll one? Bring it to me. Let me judge it, and we'll go from there. Anyway, I'm. This is gonna be. I'm gonna be few and far between. I'm moving all this stuff out of here, and I'm giving a lot of it away. And I'm gonna keep what I want to work on, and that'll be that. Seriously, I need to clean up this place a little bit, so that's what's gonna happen. And then this be that. And I'll probably end up just putting it on this side. This is a pulse motor with an external trigger. It runs on about 5 watts. What's up, Pat? You feeling lonely? Hi, I said, are you feeling lonely? What does that mean? English, please. Absolutely. We're 25 volts in. We're 5 watts in, basically. You're from Brazil? Oh, welcome, Brazil. Still. Hello, hello. Hello, hello. Yeah, I don't know, man. Ugh. Oh, yeah. Why don't I put that in there just to show you guys? Okay, now there's a magnet that goes in the bottom of this, on the bottom of this, and they repel each other. And maglev's in the center there, right about there. So it's really close to like being able to do it, but you can't use that power source. And then the cap goes on. And yes, it will spin itself basically to the extent of that 9-volt battery or another power supply. And nobody will even notice that it's like, I mean, they'll notice that it's moving and it'll look like it's moving by itself, but it's not. It's kind of rotating the rotor in the middle. And I tell everybody that too. I'll break it down like exactly the way it works. You know, this is how it works. Yeah, I had an adopted brother from Brazil. His name is Luis. Hello, hello. All right, so there's our voltage in 25 volts, 0.2 amps. That's moving quite nicely, I would say. Because we can always, I can't increase the voltage right now, but I can get a 63 volt power supply, and you can go from there. But that's as high as I can go right now, 25. Actually, the other one goes 31, but that's still not 50. Now this one right here goes from like 77, 75 up to 345. So I want to hook this up. Hello, hello. Welcome. I'm going to turn that down because this light was getting hot. Thank you, thank you. All right, so I think for my next one, I'm going to have this hooked up And we're going to try pushing like 75 volts through this system. What am I doing? I don't know. I haven't decided yet, really. It's just a motor right now with an external trigger coil. So, but I'm thinking about upping the voltage that I'm running through it to about 75 volts. Nice. So they're not, it's not that bad, I guess. Hell yeah, man. I'm like, I was, thinking to myself, how would I get to 50 volts with what I have? Like, because I blew out my other power supply and I had to throw it out. This will work. Hell yeah. Now, if we want to see that, I would have to hook up my tripod, and I could do that, but I'm not banking on that transistor being able to handle it, but we'll see what happens. And I'll have one left after that. Oh yeah. All right, need to go get my screwdriver. Touch of Joe. Right. Man, this forgot how hard those were to read. The in out is so small on this thing. In. Okay. I'm going to confiscate the wires from this comparator circuit. Man, all right. Maybe I got the wrong screwdriver head here. because it feels like it's screwed in all the way, but it isn't clamping down, so something's not right. Oh, okay, that was just, haha. Alright, well, that's what you get for confiscating, commandeering the wires from another project. Now it's too big. We'll just take these then. God, it's annoying. This is the most odd thing, and it's so tiny. I can't see that. There we go. I'll be right back. We're going to do a meter reading on this to make sure we got the voltage right. right, here we go. Yep, 73, 75. Nice. Now, we got that hooked up. We can either put this in the system or leave it out. I'm going to try it with it out first. That's awesome. You see, all right, I got to show you a few things that I just found out, man. Wow, that light was bright. All right, so we'll start by turning it on. That's how much amps we're drawing. That's our light bulb, dude. Wow. That's amazing. I can't leave it running like that for very long, though. That's so cool. I need to get my tack meter. Where'd I put it? So this is 73 volts in. No, it's just it's a 5.5, almost 6-inch rotor. It's got 4 neos in it. It's not very heavy. That's so cool. I don't know if that's real though. I mean, it's just one of these things. The voltage is real, but you know, it is pulling like 4 amps to get there. Yeah, man, this little thing is awesome. Running this big thing up here. Oh my goodness. What does it do? Well, it takes the DC from the buck converter, takes the AC from the wall, changes it to DC, and then it's running through that, and it takes the DC and the amperage from this and changes it into voltage. Nice. I didn't think I was going to be able to get to 50 volts. My cat's chewing on the cord. Indeed. The converter, no, needs 9.5 volts to turn on. Man, he keeps trying to bite the cord. I think that little bit might have shook him. Stop, Tiggs. He's really trying to get it. I might have to be done for in a minute if he keeps trying to do that. Um, it needs a minimum 9.5, and then whatever amperage it needs to turn that 9.5 into 7. There's really no like increase in power here. It's just a conversion. So yeah, so it depends on how high you turn it up. So if it's 9 volt, 9.5, you'll draw about 2 amps, and you'll get the. But I usually put about 9.7 and draw about in between 3.1 and 2.7 amps, and it's in between 70 and 75 volts. Oh, the power supply here. Yeah, I like that. But this thing does you know, transformer, high voltage transformer. And I can turn it up, man. It's only at 75 volts right now. And yeah, there's a screw in here. Like you can turn the screw and it will stop at 75 no matter what you put into it. So I like that screw. Awesome. Awesome. I like this stuff too. But I don't think this rotor's gonna end up going much faster. It's about I got it going about 1600. I don't know. I just feel like there's something about it that's gonna cap it at around 1600. And it's stuck on the pole right now. I'm gonna have to get it off. So it's not maglebbing because it's stuck on the pole. What's up, Chuck Norris? You don't sleep. You wait. No, sir. That look free to you? But when all that comes out the other side is like pure DC um, voltage instead of amperage. All right. Well, that's awesome. Thank you, thank you all very much for coming in. I appreciate it. Gonna be taking off though. So thank you very much. Peace out. Have a wonderful day. Please subscribe. Bye now.